So let me pick this one. Okay. Angular momentum measurement related problem. It is very frequent. You can. I hope you might have experienced now. Am I right? Pick up. So a wave function of a particle subjected to it's disturbing to me. Am I right? Distracting. Okay. So wave function of a particle. Okay, subjected to a spherically symmetric potential V of R. Okay. Pick up. It is given by like this. Okay. Pick up that wave function. Okay. Psi that's equal to x minus y. Okay. Plus 2z into pick up f of r. This just that okay. I mean, we have seen this kind of thing, isn't it? Which one of the following statement is true? Spherically symmetric means you can write radial part and angular part. Pick up. Now, what you have to do is you write what you call you should know that transformation equation. What is x? X is equal to r sine theta cos phi. Okay. Y is equal to r sine theta sine phi. Okay. Z is equal to r cos theta. Okay. If you substitute that one, that r you can take outside. Am I right? R is common. Okay. X is nothing but pick up. Can you guys see this part of the book? I think Google Meet record it. They can see. Pick up sine theta. Pick up cos phi minus y. Am I right? Minus or I will take it in the new page. Okay. Pick up. What is this one? Psi of r. Pick up. What is this one? X minus y plus 2z into pick up f of r. Okay. Pick up. So now r into f of r. I will keep it one side. Okay. R is common here. Okay. In each of these. What is x? Pick up sine theta cos phi. Am I right? Pick up. What is y? Sine theta sine phi. Okay. What is z? 2 cos theta. Okay. Pick up. So into r into f of r. Okay. I'll keep it one side. This is r of r. Can I write like this? This is r of r. Now this should be some linear combination of spherical harmonics. Is that okay? If I write this one, okay, pick up. If I take sine theta outside, what will happen? Sine theta common, okay. Cos phi minus sine phi. Am I right? Pick up plus 2 cos theta, okay, plus 2 cos theta into r of r. I'll write like this. These two together, I'll write r of r. Okay, pick up. Now, what is cos theta minus sine theta? Cos phi, sorry, minus sine phi. Yeah, I mean, you have to write in exponential. How do you write? E power I phi plus e power minus I phi by 2, isn't it? Minus e power I phi minus e power minus I phi divided by 2y. Am I right? How do you rearrange this one? I'll take e power I phi common. Okay, speak up. 1 by 2 minus 1 by 2y. Okay, 1 by 2 minus 1 by 2y. Okay, plus e power minus I phi common. Okay, 1 by 2 plus 1 by 2y. Pick up 1 by 2 plus 1 by 2y. Okay, pick up. So now what I can write here is okay. Pick up psi of r that's equal to sine theta e power I phi. Okay, what is the coefficient? Pick up. What is the coefficient? E power I phi. What is the coefficient? 1 by 2 minus 1 by 2i multiplied with this one. Okay, pick up. Plus 1 by 2 plus 1 by 2i. Okay, pick up sine theta e power minus I phi. Am I right? Pick up plus 2 cos theta. Pick up plus 2 cos theta r of phi. So this, what is this one? What is this one? Some a into y 1 plus 1 actually. Why? Sine theta. From cos theta it became sine theta. It is one derivative, am I right? Associated legendary function, pick up one derivative, sin theta square, e power I m phi, okay, m, y, l, m, okay, pick up, plus some b, okay, I mean, this is not exactly spherical harmonic, some normalization factor will be there, usually, okay, pick up. So this is y1 minus 1, okay, what is this one? This is 2 into some constant, okay, into y10. Y10 means it is what do you call? It is first legendary polynomial directly, not any derivative. First legendary polynomial is x equal to cos theta. Do you remember? Pick up. Somehow you should grab some logic here. Pick up. There is no e power im phi. Okay, along with cos theta, it will not come actually. That's the first legendary polynomial. I mean, when m equal to 0, associated legendary function and legendary polynomials are similar. Am I right? Pick up. Are same, I think.
Also, we can even express 2 cos theta is 2 cos theta into e to the power 0 I phi.
Yes, yes,
So
yes.
we can
You
write
can, you
m0.
can write like this: e power I into 0 into 5. I mean, once you see cos theta, you should know that is y10, okay, which will not contain e power I5 term actually, okay, pick up into r of I, okay, pick up. Now, what is the question? Pick up. It's an eigenfunction of L square with L equal to 0. It's an eigenfunction of L square. You can see here, am I right? Pick up. M value is different, am I right? But L value is same, am I right? That's why if you operate L square, okay, if you operate L square, what will come outside? H bar square, L into L plus 1, okay? If you operate L square, okay, H bar square 1 into 1 plus 1, H bar square 1 into 1 plus 1, H bar square 1 into 1 plus 1. That can be taken outside. You can write eigenvalue equation. This is an eigenstate of L square, okay? These are linear combination of, pick up, eigenstate of L square with the same eigenvalue, isn't it? Pick up. So that's why it's an eigenstate of L square with L is equal to 1. Very simple question actually. It's very simple question. Okay, I mean, only spherical harmonics that we need to remember. Look at here. Very less. I told, am I right? Pick up. I mean, you don't have to remember the whole table. At least some. You should detect that this is y1 plus 1, y1 minus 1 at least. And this is y10. Okay. You should be able to detect that one. Okay. Now, this is a linear combination of L square eigenstate with eigenvalue. Pick up h bar square 1 into 1 plus 1. 2 h bar square. Am I right? All of these, I mean, these are degenerate eigenstates of L square, isn't it? Pick up eigenvalue, L is equal to 1. I mean, 2 h bar square, okay? Pick up. In case of degeneracy, if you have a linear combination, that's also eigenstate, am I right? That kind of situation actually. Each of these are eigenstate of L square with the same eigenvalue. That means they are degenerate states, okay? Pick up. Observe it. And I hope the same thing can be done for this problem also. But this should be done because probability question, it should be done with more care actually. Okay. A rigid rotator. Okay. I mean, now that problem, what is that? In Griffiths he has given on the rigid rotator problem. I told molecular spectra. Rigid rotator eigenstate is spherical harmonics. Energy eigenstates are spherical harmonics. At least you should know that one. Okay. Speak up. A rigid rotator is in the quantum state described by this one. No, this is not any direct spherical harmonic. It's a linear combination of spherical harmonics again, isn't it? Because I'll give the hint, I'll solve in some other class. Okay, because psi of theta phi, that's equal to root of 3 by 4 phi. Okay, sine theta into e power I phi plus, sorry, minus e power minus I phi divided by 2 1. Am I right? So that's why this is nothing but root of 3 by 4 phi. Okay, sin theta e power I phi, okay, divided by 2i, okay, 1 by 2i, minus 1 by 2i root of 3 by 4 phi sin theta e power minus I phi, okay. Now you need to be careful here. You need to substitute spherical harmonics with normalization factor because he is asking measurement probability, pick up like this. So, okay, two successive measurements. Okay, it's a very nicely designed problem. I think we were to give a separate time for this one. There are 2 to 3 of such problems. I'll collect all of them. Okay, pick up two successive measurement. Okay, second probability will, okay, second one will be plus h bar if first measurement outcome is, pick up, plus h bar. It will collapse to that state. Okay, second probability is equal to 1. But to get a second measurement value plus h bar, you should have got first measurement plus h bar. That's why first measurement probability is the total probability. Hmm? I hope these look equally likely for me. Look at here, how I apply the logic. You have the same coefficient, am I right? Or at least mod square is same. That's why these two, this is y11, y1 minus. These two are equally likely. Can I say like that? Even though you substitute and all, if you normalize, you will get 1 by root 2, 1 by root. Check this out. Because I mean, I have a vector A, okay, that's equal to ax I cap plus ay j cap. Ax equal to ay. Ax equal to ay. Later I am going to normalize, make it unit vector. Okay, that's what I have seen here. Once I normalize, okay, pick up ax equal to ay, mod ax square plus mod ay square equal to 1. Then 1 by root 2, 1 by root 2 will come in the normalization, isn't it? Equally like, or I mean, each of these components are equally weighted, right? Can I say like this? Equally weighted. That's how I can see here. That's why. So probability of getting this one. Okay, what is this one? I mean, this is y1 plus 1, y1 minus 1. He's asking plus h bar. If you want to get second measurement plus h bar, first state should have been collapsed to plus h bar eigenstate. Okay, that's why first probability is the total probability. That's why that is equal to half, 50-50. Hmm? Okay. But we shall solve some problem together. That's better. Hmm? Yeah.
But if the first measurement is LZ, next measurement is LX, then
No. He said successive measurement of LZ actually.
oh, sir,
That spin method, like spin measurement. Then it would be different. And after the measurement, you take the state, you expand in terms of eigenstate of other operator, just like we did for the spin measurement. Okay, pick up. Hmm? So if first measurement collapse to y1 plus 1, okay, if first measurement outcome is plus h bar, then it will collapse to y1 plus 1, the eigenstate of LZ with eigenvalue plus h bar, pick up. Hmm? So then if you do second measurement on this one, you will definitely get plus h bar. Am I right? Hmm? You are, again, I don't know how, I will come out with some symbols, okay, pick up. You are doing LZ cap measurement on psi. You are getting h bar as a outcome. Okay, then state will collapse to this one. If you do one more LZ measurement on this one, you'll get h bar only with 100% probability. But this probability is not 100%. Am I right? If you want to get second measurement plus h bar, you should have got first measurement plus h bar. Look at here, how they include the concept here. Collapsing of the state. Figure. And mathematics is nothing here. Actually. I mean, no mathematics, only algebra if you do. Okay, and even if you observe this logic, that 0.5 probability, it will come without anything. Am I right? And one more thing you observe, okay, one more thing it is there, the coefficient, I mean the normalization factor of this one and this one, or y11, y1 minus 1, okay, y11, y1 minus 1, okay, they may be differed by one negative sign, okay, but mod square is the same actually. So somehow when you put y11, y11 minus 1 here, weightages are same. Weightage means their coefficients will be same. After normalization, 1 by root 2, 1 by root 2. Maybe a minus a, you can take like this. Okay, minus a, but weightages are same. Okay, okay. In a spherically symmetric potential, okay, it is given by x plus y plus 3z is equal to f of r. The expectation value, okay, we shall do this. No. We did only probability. I mean, what are the possible measurement? That's easy. That earlier problem, possible measurement outcome, that was easy actually. This was more easy. Okay. Eigen function of, I mean, pick up this eigen function of L square with this eigenvalue, right? We have seen this. This was a combination of y11, y1 minus 1, y10. Am I right? Pick up. So L was same. Okay. So that's why L is equal to 1, I think. Am I right? Because this eigen, I mean, this is a linear combination of this one. Each of them are eigenstate of L square with L equal to 1 eigenvalue. Linear combination is also eigenstate, isn't it? Degenerate eigenstates, isn't it? Because this was easy actually, okay? Because that didn't require much manipulation. But this, he's asking what is that expectation value of L square for this state. Because, So let us start like this, okay? Psi of R actually, okay, that's equal to x equal to R, pick up sine theta cos phi plus sine theta sine phi plus cos theta, okay, whole thing multiplied with, pick up whole thing, R is common, okay, pick up R into, pick up what he has written, f of R, am I right? Pick up R into f of R, okay, pick up. These are spherical harmonics part. Okay, this is your radial part. Okay, you can say like this. Okay, what we have written, this is sine theta cos phi. We have written, I think this is, we have written something. Yes, this is 3 here. No? Yes, sir. 3 here. Hmm? Be careful. That weightage is important while talking about probability and average value. Okay, possible outcomes and all, it doesn't matter. Weightage doesn't matter. But so for probability, that weightage doesn't matter. Weightage means individual term weightage. That's what I'm talking about. Okay, I think what we have written, sine theta e power I5 plus e power minus I5 by 2. Okay, plus sine theta e power I5 minus e power minus I5 by 2i plus 3 cos theta. Figure 3 cos theta r of r. I'll write like this. Okay, figure. Both of them together, I call it as radial part of the wave function. Okay, figure. So now what I have to do? I have to take sine theta outside. Right? What I mean, e power I5 outside. Okay, figure. So e power I5 outside. Okay. So sine theta also common. What is the coefficient?
Half
1
plus
by
1 by
2
2i.
plus 1 by 2y. Am I right? If I'm not wrong. Okay. Correct me. So 1 by 2 minus 1 by 2y. Okay. Pick up. So what is this one?
Sine
Sine
theta e
theta.
to the power minus I5.
Sine theta e power minus I5. I think if we think, I mean, there may be other better way. Okay. 3 into cos theta. Am I right? Pick up. Now you need spherical harmonics table. You need spherical harmonics table. This is y11, this is y1 minus 1, this is y10. Okay, you have to substitute along with that normalization factor. You have the table. Any other way? No, because these have different weights. Actually. So I can't think of any other way. Okay, speak up. So now what I'm saying is you need to list out them with where is it? Okay, you need y11. Am I right? Plus 1. That is this one. I mean, with some constant, okay? That's equal to what is this one? Minus 3 by 8 pi under root, okay? Pick up. Minus under root of 3 by 8 pi, okay? Pick up sine theta e power I pi, okay? Pick up. Y1 minus 1, that's equal to, so plus root of 3 by 8 pi, okay? So sine theta e power minus I pi, okay? Pick up. And y10, okay? So that's nothing but 3 by 4 pi actually, root of 3 by 4 pi cos theta. No, you need to do that. Tell me if you guys find any way. Okay, speak up psi of r. Now you don't have to worry about this one. Okay, you can just see this linear combination. Okay, pick up linear combination of spherical harmonies. Okay, pick up. That's why this is equal to, look at here, 1 by 2 plus 1 by 2i. How do you write this one? 2 plus 2i by 4i. Am I right? I'll write like this. Okay, 4i. So sine theta e power I phi is, okay, root of 8 pi by 3, okay, minus as a whole, am I right? Into y, pick up 1 plus 1. You don't directly write y11, y1 minus 1, y10 because their relative coefficients are different. Am I right? Because that weights will be different. You can't directly, I mean, leaving this normalization factor, you can't directly substitute actually. Just think relative weight. A vector direction, okay, that is decided by relative weights of its component, ax, ay, az. Am I right? That you should not what you call alter. Am I right? Pick up as a whole. Now I have some ideas here. Hmm? You are free to multiply the whole series by anything. Vector A, that's equal to ax I cap, okay, plus ay j cap plus az k cap, okay. If you multiply the whole thing by, I mean, this is just like what you call, these are the bases, these are the coefficient. I cap, j cap, k cap are the bases. If you multiply a vector whole by a constant, this direction is not changing. Later you can normalize, isn't it? That's why to simplify the next step, what I do is, I'm going to multiply the whole thing by 4i. I'm going to multiply the whole thing by root 3. I'm going to divide the whole thing by root 85. What do you think? Or take something common and throw this out. Pick up. Can I take 1 by 4i common? Can I take root of 8, 5 by 3 common? Is that okay? If I do that one, okay, minus 2 plus 2i, okay, y1 plus 1, okay, plus minus 2 plus 2y, okay, pick up y 1 minus, I mean, I'm trying to make the step easier here, okay, pick up plus 4i is taken outside, 4i into 3, am I right? So here one more root 2 was required, divide by root 2, okay, am I right? Multiply and divide by root 2 so that you can take root of 8 5 by 3 outside. Be careful, isn't it? So tell me if I'm wrong, okay, y10, okay, r of r, okay. Now I will just throw this off, or I will multiply the whole thing by reciprocal of this. This doesn't matter. I'll take only these. Pick up. What is this one? Oh, this is so lengthy. Minus 2 plus 2i. Okay, pick up. y1 plus 1 plus minus 2 plus 2i. Okay, pick up. y1 minus 1 plus 12i by root 2. Am I right? y10. Okay, pick up. R of r. You don't have to take this one now. Now you place one constant a and you normalize only this part. This part can be normalized separately. You need only spherical harmonics part actually. Okay, pick up. How do you normalize? Pick up mod a square. Now look at here. This is the coefficient. After you take a inside, C1, C2, C3. Can I say like this? Okay. Mod C1 square, mod C2 square, mod C3 square. Okay. Mod a square. Okay. Multiplied with mod of this one. What is mod of this one? Mod square of this one? 4 plus 4. 8. 8. It's also 4 plus 4. 8. Because what is this one? 144 divided by 2. Am I right? 12 square, mod square. 144 divided by 2. 72. Pick up. So is equal to 1. Okay. Pick up. Mod a square is equal to, what is this one? 88. Okay. 1 by 88 is equal to 1 by root 88. Can you simplify? 4 into 22. 4 into 22. 1 by 2 root 22. Now when you substitute a, okay, your psi of r would be, because it will be a bit easy actually, okay, because 2 you can take common, minus 1 plus I by root 22, okay, y1 plus 1, okay, plus minus 1 plus I by root 22, okay, y1 minus 1. Okay. So what is this one? I think 6I divided by root 44 actually. Am I right?
So I think we can
Hmm.
say like bit different. For L square for this is 2h bar square now, sir. For this. For
No,
all
what you
L-
need here is okay, expectation values required. You need probability of each.
No, sir. For each,
Okay.
for each it is L square. Same value. It's 2h bar.
It is 100% probability.
We don't have
Why I'm doing these things?
so
If you take I mean, if you do measurement, okay, L square measurement. I didn't see this one. Okay, you could have what you call stopped here itself. You could have stopped here itself. Why? You know, these are all what you call eigenstate of L square with that quantum number L equal to 1. Am I right? Now, if you take identically prepared system, if you do L square measurement, what is the outcome? H bar square 1 into 1 plus 1. And average H bar square 1 into 1 plus 1. LZ expectation would require this one actually because LZ outcomes are different. This is not required. At least, I mean, but some other problem requires this one. That Weikelin problem that I asked in the exam, that requires this kind of approach, but not this lengthy. Yes, sir. You are also doing that one?
yes, sir. I did that.
Are you done? Fine. Okay. What you got here is, okay, the state psi of r, okay, it doesn't matter. A into y1 plus 1, okay, plus b into y1 minus 1 plus c into y1 0. It doesn't matter. Now, if you do L square measurement on this one, pick up. This is a L square eigenstate actually. With eigenvalue, pick up. With eigenvalue, h bar square L into L plus 1 or 2 h bar square. L equal to 1 here. Am I right? Pick up. Linear combination of these things are also eigenstate. Am I right? In its own eigenstate, expectation value is that eigenvalue itself. Pick up. It is a degeneracy situation, isn't it? Oh, this one page was sufficient. Be careful, okay? Be careful because, I mean, or if suppose problem goes this much length, you leave it. That means at that time you couldn't figure it out. That it can do
something wrong.
something wrong sometimes. Okay,
I
no, no.
get the
Some
same answer.
some TAFR and just problems are bit strange. Some problem, if you look in one perspective, it is nothing actually. Some problem, whatever what you call perspective you look, they demand that mathematics to be done actually. They demand that mathematics to be done. Okay. Some problem when you look at that perspective, I mean, it looks like nothing actually. Problem looks like nothing. It's a way of thinking problem. More than 50%. Just problem also. Okay. Pick up. There was one electrical circuit problem. Okay. Pick up. I mean, usually, I mean, in JE and all, they ask that kind of problem. Okay. It's just a symmetry. Current will divide. If you do nothing actually, if you see that one, okay, it has a symmetry and currents are dividing equally. Problem is nothing actually. If you start applying Kirchhoff voltage law, I mean, it takes a full day. Pick up like that. So now that's what I'm saying. This is just our TAFR. TAFR. Yeah, that's it. Okay, you understood the property. Okay, this is also eigenstate. In its eigenstate, eigenvalue itself is what you call expectation value. Or you think like this: you have identically prepared system. You did the measurement. Whatever the state it collapsed, we don't know. But outcome of the measurement is this one only. Am I right? Pick up. So clockwise direction. Am I right? Positive rotation about positive y-axis in a counterclockwise direction. That's what they said. Sign was the what you call confusion here. Am I right? Pick up. You have Zetili? Rotation by an angle epsilon. Okay. Along y-axis. Am I right? What is this one? 1 minus
I epsilon by h.
e power minus I think epsilon by h bar into Lx. Am I right? If you take first two term in this expansion, 1 minus I epsilon by h bar into Lx. Am I right?
L-
Ly.
Ly.
Ly here. Okay. If you are taking like this, what you are getting? I mean, you are getting any problem?
So if we take this, then we are getting the right answer, but this we are the right for clockwise rotation.
Okay, but what if you take this one? Will you get any answer?
So if we take this, we are getting an answer, but the answers are not matching with the options.
Ah, that's what I'm saying. I mean, there is that convention is not so well defined in the text, clockwise or anti-clockwise. In quantum mechanics, classically they have mentioned properly. Okay, in quantum mechanics, clockwise or anti-clockwise, that convention is not. I mean, if you apply this one, you are not getting any answer. If you are applying this one, you are getting one of the answer. That is the right answer also. Am I right? Because I mean, in the file name you have answer. Am I right? File name you have answer. Okay. So that's what I told. Am I right? They are not mentioning any convention. Okay. Answer B. If you are getting answer B, that's right. Okay. Okay. But you are saying this is clockwise. Am I right? Okay. Let me check out. Just like in classical rotation, X and Z will happen in one way. Why the sign was changed? Do you remember? Sin theta minus sin theta, that sign was interchanged for Y. Do you remember?
Yes, sir.
Whether the same thing happens for in quantum. Let us see that. Okay, because why? Am I right? Hmm? I mean, only in this question they talked about what you call clockwise or anti-clockwise. In most of the questions, they don't talk about clockwise or anti-clockwise. Okay, speak up.
Mhm.
So that's why you pick this one. Let me check whether if X and Z, one thing will happen, for Y, other thing will happen, just like in classical rotation. It happened, am I right? In classical rotation. You remember Rx of theta. Okay, this is cos theta, sin theta minus sin theta, cos theta, 0. No, this is Z actually. Am I right? RZ, 0, 0, 1. Am I right? Pick up. But if you take the, I mean, same, suppose clockwise, anti-clockwise, whatever, the same, what you call, convention, okay, for Ry of theta, this will interchange. Pick up cos theta minus sin theta, pick up sin theta, cos, sorry, Ry, am I right? Pick up cos theta, 0, 1, 0, 0, 0, minus sin theta, pick up sin
Sin theta, cos theta.
cos theta, okay? I mean, how this is interchanged. Whether the same thing happens for quantum mechanics, we need to check that out. Okay. Let us see what is the argument behind this one. Okay. It is given in Merrill-Bose. How for Y it is changed actually. Okay. So because in that infinitesimal rotation, okay, whatever the epsilon that we have taken, here it is there actually. Okay. We started with this one actually. Later we found this one. Okay. Just think over it. Okay.
When we go on anti-clockwise direction,
Hmm.
in the first part,
Hmm.
it is going from positive, X will remain positive, like if you compare to a clockwise direction
Hmm.
in the same.
Hmm.
But why will go from positive to negative? If you see the first quadrant,
No, this is rotation about Y actually. Rotation about Y. Okay, it may be XYZ convention. Okay, just read out. Okay, it is there. Okay, it is given. I mean, how this differed. Okay, argument is given. Solved argument. Okay, so I mean, if that in that argument, if we change this one, okay, we have to change here. Then this will be changed. Am I right? Okay. So we took infinitesimal rotation, then we made finite rotation. Okay, just observe that one. I think it can be done. Okay. Hmm? So what we had there, do you remember? I mean, J is equal to L plus S. Am I right? Hmm. And J square comma. So now I think it's a other problem, not that problem. In that problem, L dot S commutation with all stuff. Okay, pick up. It is other problem from Griffiths. Okay, pick up. I think after addition of I gave because it was there after addition of angular momentum. Problem 4.41. Do work it yourself. Okay. Problem or in Jatili after addition of angular momentum. Okay. I mean, in Griffiths we have done this is S1, S2, S. Okay, that's all we did. Okay, addition of angular moment. Okay, or in Jatili after, I mean, the symbol J, whatever I have taken, I think from Jatili. Okay, after addition of angular moment. Okay, this also in Griffiths also after addition of angular moment he gave this problem. In Jatili after addition of angular moment, if you look into that one, you will find this. Okay, because work it out maybe. Wait a second, whether we can eliminate option. If this J1 is actually cross product with itself is non-zero, have you proved that one? Angular momentum, whatever angular momentum you have, okay, J vector, okay, J I vector or whatever you have, okay, cross J vector, this is non-zero. I think this is I H bar J again Jtj. Prove this one also. No, what I mean, I told that angular momentum chapter of Jtj is required. Am I right? I mean, if you have time, you got to work more. Okay, equation 5.17. Okay, equation 5.17. Okay, general formalism of angular momentum. First step he proved this one actually. J cross J is equal to I H bar J itself. It was some old question again. Okay, because, I mean, this was not required for that theory actually. That's why I didn't prove. Okay, in Griffiths. Okay. Now this particular problem is very nicely defined. Consider an eigenstate of L square and Lz. Okay, denoted by Lm. Okay. So ket Lm. That's the eigenstate of L square and Lz. Okay. Where operator A cap, that's equal to, because n cap dot L vector. Okay, n cap dot L vector. Okay, where n cap is a unit vector parameterized in terms of two angles. What do you mean by it? That's your R cap, whatever we have taken in arbitrary spin measurement problem. But here something is missing. Sin theta cos phi, sin theta sin phi, cos theta should be there. Because n cap is parameterized by two angles, theta and phi. Am I right? Any direction in space, in spherical polar coordinate, any direction in space can be characterized by theta and phi. I think I already talked about that. Am I right? Hmm? You have some n cap here, okay, with theta and phi. You can characterize that particular unit vector direction. Right? Because I need a unit vector. R coordinate is not required. Okay, because theta and phi. Okay, because that's for this n cap. Okay, its component. Oh, because its components are sin theta, cos phi, sin theta, cos phi I cap, sin theta sin phi j cap. Okay, so cos theta k cap. Am I right? Cos theta k cap. Now look at here. In terms of two angle, I mean, I hope you understood what is n cap properly. Okay, that's what he's talking about. Okay, the width delta A in Lm. What do you mean by width delta A? He's talking about standard deviation. It has different name. That okay? Pick up delta A, whatever he means. Okay, he's talking about standard deviation in the measurement of A. Is that okay? Now look at here. You should eliminate often. You should not try to get into the exact one by solving. You can eliminate often. They have given question like that, or they may be expecting the same. Okay. Now elimination of the option, it is like this. Look at here. Okay. This is the state in which we are doing standard division. Okay. A cap is n cap. N cap is unit vector dot L vector. Okay. If n cap is when n cap is if n cap is equal to I cap, or I will start with n cap is equal to k cap. What is a cap? Z axis. N cap is along Z axis. Lz. Now in Lz, okay, this state is eigenstate of Lz. There is no standard deviation. sigma LZ is equal to 0 in this state. Why? The state is definite state of LZ operator. Isn't it? Eigenstate. You got my point? Hmm? Now, if n, I mean, this is not sufficient. Okay. If n cap is equal to k cap, what is theta and phi? What is theta? Theta equal to 0. Phi is, I think, arbitrary, or I don't know. We shall define in electrodynamics. Okay. Pick up. Theta is equal to, pick up, 0 degree. Am I right? When theta is equal to 0 degree, your sigma is 0. Am I right? Pick up. Which option satisfied? When theta is equal to 0 degree, it should be 0. Am I right? So you can avoid these two because cos theta will not be 0 when theta equal to 0 degree. Pick up. But other two, still you have confusion. You have to do much more, isn't it? You got my point? Are you getting my point on Google Meet?
Why is M cap?
I took one special case. I'm trying to eliminate option. N cap is arbitrary, he has given. Okay. I took one special case to eliminate the option. Pick up. Hmm? Or you can start like this. Okay. Pick up. You can start like this. Okay. Don't forget our state is this one. Okay. Pick up. State is this one. Okay. Which is a simultaneous eigenstate of L square and Lz. Okay. Pick up. Or I will say when theta equal to 0. Pick up. When theta equal to 0, n cap is equal to k cap, then your a cap is nothing but Lz, sigma Lz equal to 0. Okay, you can avoid two options over there. Okay, so when theta is equal to 90 degree, there are and phi is equal to 0 degree. I'll take like this. Okay, that is n cap is I cap along. Am I right? Theta is equal to 90 degree, phi equal to 0. It is along x axis. Okay, speak up. Then a cap will be Lx. Am I right? Speak up. Now you need to find sigma Lx. Sigma Lx will be non-zero. You need to find this so that you can eliminate one more option. Okay, pick up. How do you find sigma Lx in this state? Pick up. That is that what you call Gettily problem. Sigma Lx in state Lm. Am I right? Pick up. That means you need expectation Lx in this state. What is expectation Lx?
L square minus L.
Lx contain L plus and L minus. You have to sandwich between Lm. It will rise or lower the state. It is 0. Or you write like this. Okay. Lm. Okay. L plus L minus by 2. I think. Okay. Lm. Right. It will either lower the state, rise the state, orthogonal 0. So while finding expectation Ls square, I gave one idea. What is that one?
L
Now
square.
don't do using operator. It will be a bit time consuming. So idea is expectation Lx square is equal to expectation Ly square. You need to remember this one. Now expectation L square you know. That's equal to expectation Lx square plus expectation Ly square plus expectation Lz square. So this one is nothing but expectation Lx square plus, or I'll take this Lz square here. Expectation L square minus expectation Lz square. That's equal to these two are equal. That's why 2 times expectation Lx square. That's why expectation Lx square is equal to 1 by 2 times. Okay, expectation L square minus expectation Lz square. This will happen. Remember only in this state. Okay, don't write the same thing for linear combination state. Okay, because whenever we explore some trick, you should know the validity of the trick. Okay, because that's equal to expectation L square minus expectation Lz square. These two are very easy to find because this is eigenstate of L square, eigenstate of Lz, isn't it? Because half of I think h bar square, okay, L into L plus 1 minus m
Minus M square.
because and your sigma Lx that's equal to root of expectation Lx square minus expectation Lx the whole square that's equal to, I think expectation Lx equal to 0. This simply root of expectation Lx square, simply root of this one is equal to h bar. I think root of L into L plus 1 minus m square whole divided by 2. Okay, you have option. This is sufficient, isn't it? When theta is equal to, pick up, 90 degrees. Okay. When theta is equal to 90 degrees, sin theta is equal to 1. Okay. Pick up. This is the right option. Here you don't have 2 in the denominator. Is that it?
Suppose you have to try to solve this.
Now, if you wish to solve this, I couldn't get how to solve this because we solved all of this by ladder operator. Now, how do you write this one in terms of ladder operator? Okay. Now, what you need to do is you have to substitute n cap here in terms of I cap, j cap, k cap. Multiply. You will get in terms of Lx, Ly, Lz. Write them in ladder operator. Then take those average, you will get it. Now, that is very huge step. Okay. N cap dot L vector. Okay. Speak up. What is n cap? Sin theta cos phi I cap plus sin theta sin phi j cap plus cos theta. I mean, this is what we did actually in that spin measurement problem. Okay. Lx I cap plus Ly j cap plus Lz k cap. Okay. Now individually multiply. You will get Lx into this term, Ly into this term, Lz into this term. You write that one in terms of ladder operator. Okay. I'll say this is Ln. Okay. So then Ln average you need to find. Okay. In the state NLN. Okay. Then Ln square the average is 2 NLN. They may be expecting you to eliminate the option. Then you should not go with the ideal steps. Okay. That should run in your mind parallelly, whether I can eliminate option. Because they may be expecting the same.
There will be some kind of questions where we have not covered, where it might be possible to eliminate the options. But that intuition won't come if you haven't done the entire, what do you say, calculation.
No. What I am saying is we are doing a lot of derivation. Okay. I mean, compared to this exam preparation. Because, I mean, why I followed this method? Because that intuition should be there. Elimination of option. Okay. But what I am saying is, but that approach, when you go to exam hall, that should be different. How you think, am I right? You should not try to do the problem ideally. You are look at here. While learning, your attitude should be different. In the exam hall, your attitude should be different. You should try to get the right answer. Who cares how you did? Isn't it? Or they are asking questions in that perspective. That's what I'm saying. Especially in TAF or in just exam. Okay, they are asking the question in the perspective of you can eliminate option. Some question, hard mathematics, they are expecting you to do that. Okay, that's why when you see that one, okay, that should be running in your mind parallelly, whether I can eliminate option. This is a generalized question, am I right? By taking some special case, whether I can eliminate option. This is the usual technique actually we do. They will give one generalized problem. You know the special case answer. You use that your special case answer to solve that generalized problem. Because generalized derivation would be very difficult. Is that okay? I'm saying many problems can be done in this idea. What is that? They will give generalized problem. You know the answer of some special case. Okay? You just use that one to eliminate option. Okay? Sometimes they will expect generalized answer only. I mean, they will not allow you to eliminate option. They will expect. But that will, most of the case, that will work actually. What I'm saying is, pick up. Generalized question. Okay? Generalized formula or derivation. Okay? Pick up. Given expecting or expecting. Pick up. In the question. You now special case formula or derivation or answer. Pick up. What is that one? Try to eliminate option. Try to eliminate option. If you are unable to eliminate option, they are expecting you to do that now. If you are able to eliminate option, either they haven't taken care while designing the option, or they have designed the option so as to eliminate the option. Is that okay? Yeah. That's how you deal in exam. Okay. Yeah.